In this video, we will be determining the rate of change of a linear relation from its graph. Here's our first graph. A town's reserve oil tank, which holds 8,000 liters of oil, is being filled at a constant rate. The graph below represents this situation. First, we need to identify the independent and dependent variables. Next, we need to determine the rate of change of this relation, then describe what it represents. The independent variable is on the horizontal axis, and this is time t. The dependent variable is on the vertical axis. This is the volume V. Next, we determine rate of change. Choose 2 points on the line. These are selected because they're both on the grid lines. The rate of change is the change in the dependent variable divided by the change in the independent variable. The change in independent variable from red point to red point is a change of 100 minutes. The vertical change between the two red points is an increase of 4,000 liters. So our rate of change is 4,000 liters divided by 100 minutes, which can be simplified to 40 liters per 1 minute, or just simply 40 liters per minute. The rate is positive, meaning the volume is increasing. Every minute, 40 liters of oil are added to the tank. We also could have chosen these 2 points because they also lie on the grid lines. Our horizontal change between the 2 points is an increase of 100 minutes. The vertical change between the 2 points is an increase of 4,000 liters. 8,000 liters subtract 4,000 liters, giving us a change of 4,000 liters. So our rate of change is once again 4,000 liters divided by 100 minutes, which can be simplified to 40 liters per minute. So it's the same rate. We also could have chosen these 2 points, the end points, because they also lie on grid lines. The horizontal change between the two red points would be 200 minutes, and the vertical change between the two red points would be an increase of 8,000 liters. So our rate of change can be written as 8,000 liters divided by 200 minutes, which once again can be simplified to 40 liters per minute. It doesn't matter which points you choose as long as they lie on the line. And hopefully they also lie on the grid lines. Here's our second graph. The reserve oil tank, which holds 8,000 liters of oil, is being drained at a constant rate. The graph below represents this situation. Once again, identify the independent and dependent variables and determine the rate of change of this relation, then describe what it represents. On the horizontal axis is our independent variable, which is time t. On the vertical axis is our dependent variable, which is volume V. Next, let's determine the rate of change and describe what it represents. Let's use these 2 red points. The rate of change is the change in dependent variable divided by change in independent variable. The vertical change is negative 8,000 liters. The horizontal change between the 2 red points is an increase of 80 minutes. So our rate of change is negative 8,000 liters divided by 80 minutes, which can be simplified to negative 100 liters per minute. The rate is negative because the volume is decreasing, and every minute 100 liters of oil are removed from the tank. Or we could have used these 2 points. The vertical change would be negative 2,000 liters. The horizontal change would be positive 20 minutes, giving us a rate of change of negative 2,000 liters divided by 20 minutes, which can be simplified to negative 100 liters per minute, the same rate. Or we could have used these 2 points, where the rate of change is the change in the dependent variable, negative 2,000 liters, divided by the change in the independent variable, which is positive 20 minutes. We have negative 2,000 liters divided by 20 minutes, giving us the same rate of negative 100 liters per minute. Here's some practice. The graph shows the altitude of a drone as it lifts off. The graph below represents this situation. Altitude is the height above ground. First, we need to identify the independent variables and the dependent variables. Next, we need to determine the rate of change of this relation, then describe what it represents. On the horizontal axis, we see time. This is the independent variable time t. On the vertical axis, we see altitude in meters. This is the dependent variable, altitude a. Next, we need to determine the rate of change and then describe what it represents. Let's use these 2 points at the endpoints. The rate of change is the change in dependent variable divided by the change in the independent variable. The horizontal change between the 2 red points is positive 120 seconds. The vertical change between the 2 points is an increase of 480 meters. This is the change in the dependent variable, 480 meters. Our rate of change is 480 meters divided by 120 seconds. So our rate of change is 4 meters per second. The rate is positive, meaning the altitude is increasing. Every second, the drone climbs 4 meters. We also could have used these 2 points. The horizontal change between the 2 red points is positive 60 seconds. The vertical change between the 2 red points is an increase of 240 meters. Our rate of change is 240 meters divided by 60 seconds, which can once again be simplified to 4 meters per second. This is the same rate, and every second the drone climbs 4 meters. Please proceed to the next activity in this lesson. Thank you for viewing.